inverse Laplace transforms. If L of f of t equals f of s, then its inverse is, just take this L to this side, then L inverse of f of s equal to f of t. L inverse of capital F of s equal to f of t. This is called inverse linear transformation. Sorry, inverse Laplace transformation. That is, inverse Laplace transformation of capital F of s is equal to f of t. We have already seen results. L of 0 equal to 0. Then L inverse 0 equal to 0. Okay. L of 1 is equal to 1 by s. Then L inverse 1 by s equal to 1. Okay. L of t is equal to 1 by s square. There we know. Then L inverse of 1 by s square is equal to t, etc. L of t raised to n is n factorial by s raised to n plus 1. Then L inverse of n factorial by s raised to n plus 1 is equal to t raised to. In this case, we have all the results and inverses. And actually, we find the inverse Laplace transform of a function of s, and the answer is a function of t. Okay. And inverse Laplace transform is linear also. L inverse of alpha into f of s plus beta into g of s equal to constant can be taken outside, alpha and L inverse of s plus beta and L inverse of g of s. Okay. Next, we have some problems. That is, find the inverse Laplace transform of. Question is, find the inverse Laplace transform of 1 by s raised to 5. Then L inverse of 1 by s raised to 5. That is a question. But we have a n factorial by s raised to n plus 1. L inverse of n factorial by s raised to n plus 1 is equal to t raised to n. Therefore, here s raised to n plus 1. That is s raised to 4 plus 1 here. Then numerator should be n factorial. N factorial by s raised to n plus 1. Its inverse is t raised to n. Here it is t raised to 4. It is inverse. But we have only given 1 by s raised to 5. Therefore, we have to adjust the factor 4 factorial by s raised to 4 plus 1 and into 1 by 4 factorial. Then this is standard. L inverse of n factorial by s raised to n plus 1 is equal to t raised to n. Okay. So, result is 1 by 4 factorial into t raised to 4. Value is t raised to 4. Okay. This is a method. And in some other problems, L inverse of s square plus 7. This is s square plus k square denominator. S square plus root 7 whole square, you can write. And numerator also should be k by s square plus k square. Then only its inverse is sin kt. Numerator is, there is no s. If there is an s, then its inverse will be cos kt. But here there is no s in the numerator, then it is the inverse of sin kt. So inverse it will be sin kt. For that we are adjusting this k here. S square plus k square, then we have to be in the numerator a number k. That is, for that we are putting k here. S square plus k square here, when root 7 is the k. K by s square plus k square. Then for that root 7 we are adjusting 1 by root 7. So that cancels. Then finding the inverse, 1 by root 7 is constant outside, and L inverse of root 7 by s square plus root 7 square is sin kt, that is sin root 7 t, and 1 by root 7 is outside. Okay. And some other result is minus 2s plus 6 by s square plus 4. Here also we can divide by this s square plus 4, this term and this term. That is minus 2 into s by s square plus 4 plus 6 by s square plus 4. This is, in the numerator we have s here, therefore this inverse will be some cos kt. And here numerator constant, therefore this inverse will be sin kt. For that we have to adjust. The denominator is s square plus 2 square, then k is 2. Then here s square plus 2 square, numerator should be 2. For that we are putting a 2 and 1 by 2 here. Okay. Likewise you have this minus 2 into L inverse of S by S square plus standard result. L inverse of S by S square plus K square. Plus 6 into adjusting. For that K we are putting a 2 here and 1 by 2 here. Okay. L inverse 2 by S square plus 2 square. So answer is minus 2. This is cos kt, that is cos 2t. And 6 by 2 is 3. And inverse 2 by S square plus 2 square is sin kt, that is sin 2t. Okay. That's the method. And again, in the next problem also, you can see 2 by s minus 1 by s cube all square. We can expand it using a minus b all square. We are getting this result. And inverse of this each one is standard, that is s raised to n plus 1 is in the denominator. S raised to 1 plus 1, s raised to 3 plus 1, s raised to 5 plus 1. So that accordingly we have to adjust the numerator. For that s raised to 4, for example s raised to 4, s raised to 3 plus 1, we have to put in numerator 3 factorial, therefore 1 by 3 factorial into 3 factorial. And s raised to 6 we have s raised to 5 plus 1, we are adjusting, numerator will be 5 factorial, we are adjusting 1 by 5 factorial into 5 factorial. Okay. Likewise you can find the inverse. And in the next problem, that is problem is s plus 2 whole square by s, all s cube. S plus 2 whole square by s cube. In that problem, we can expand it. We can expand s plus 2 whole square. First, using a plus b whole square, expanding by s cube is here, and dividing each term, s square by s cube, 4s by s cube, 4 by s cube. And we are getting 1 by s square, okay, etc. And it can be adjusted, as in the above problem, it can be adjusted. Okay. This is a method to find inverse Laplace transform of some simple problems. But in some other problems, we may have a fraction, given fraction. What is a fraction? Fraction is of the form f of s by g of s. Numerator will be a function of s divided by denominator by function. These are polynomials. Numerator and denominator are polynomials. Then, if in the denominator g of s contains a linear factor, a factor of the form, suppose here we have first of all we take f of s by g of s, and the denominator g of s is of the product of linear factors, that is s minus a1, s minus a2, etc., s minus a. Denominator, if in the denominator we have a factor of the form s minus something, suppose s plus 4, it is s plus 4 means s minus minus 4, or s simply s means s minus 0, or s minus 3, or s plus 5, such factors. If there is such a factor in the denominator, we can simplify it into partial fractions. That is, if there is an s minus a1, we have a fraction of the form a constant by s minus a1. If there is an s minus a2 in the denominator, we take some a2 by s minus a2. And if there is an s minus an in the denominator, we take an by s minus an. These a1, a2, etc. n are constants that is to be determined. And when writing in this manner, it is easy to find its inverse. It is not easy to find the inverse of this, but here it is easy to find the inverse. For that, we are transforming it into partial fractions. The rule here applied is, if the denominator has a factor of the form linear factor, that is no square, no s square here, no whole square also here, simply s minus a1, or simply you can have, for example, s you can consider as s minus 0, or s plus 5, that is s minus minus 5, or s minus 3, such terms. Corresponding each such term, we are putting a constant in the numerator, a1 by s minus a1, for next a2 by s minus a2, etc. For the last n by s minus a, etc. And we have to find these values. But when we write in this manner, just transforming the given fraction into partial fractions, so many fractions, it is easy to find the inverse because we know the inverse of 1 by s minus a1. What is inverse of 1 by s minus a? It is e raised to at because Laplace transform of e raised to at is 1 by s minus a. Laplace transform of e raised to at, L of e raised to at is 1 by s minus a. Therefore, L inverse of 1 by s minus a is e raised to at. Okay. Therefore, it is easy to find inverse, L inverse of 1 by s minus a, L inverse of 1 by s minus a2, etc. It's easy to find. Standard result, 1 by s minus a, then its L inverse is e raised to at. Then what is L inverse of 1 by s minus a1? E raised to a1t. L inverse of 1 by s minus a2 is e raised to a2t. Constant can be taken outside. And L inverse of 1 by s minus an is e raised to ant. Okay. This is another method. In some problems, we may have to convert it into partial fractions. For that, we are using the rule, if the denominator has a fraction of the form, this linear factors, then corresponding fraction will be of this type. Okay. But usually we have in question paper simple problems that we have already discussed, such problems only. But may come this type of questions. So many examples are here, so many problems are done in the notebook. You just see that problems. Okay. And now we can take such a problem that is to find the inverse Laplace transform of what is s plus 1 by s square minus 4s. It's a simple example. S plus 1 by s square minus 4s. Suppose this is a question. S plus 1 by s square minus 4s. To find the L inverse of this. It's a question that is not easy. No standard result here. It is not easy to divide by each term. S by s square minus 4s plus 1 by s square. This is not applicable here. In such cases, we can see that this is s plus 1 by s square minus 4s can be written as s into s minus 4. It's a product of linear factors in the denominator. S is s minus 0. This is s minus 4. These are two linear factors. Then we take this equal to some a1 by s corresponding to this numerator a1 plus next for s minus 4 we are taking a2 by s minus 4. We have to find this a1 and a2. For a1 and a2, to find a1 and a2, the method is multiply by this denominator on both sides. Multiplying both sides by s into s minus 4. Then what happens? Multiplying both sides by s into s minus 4, and we get here s plus 1 only. For this term, we are multiplying by s into s minus 4, then s cancels. We are getting a1 into s minus 4. Plus next, multiplying s into s minus 4 here, s minus 4 cancels. We are getting s in the numerator, that is some a2 into s. From this result, you can find a1 and a2. How? Just putting s equal to 0, this a2 vanishes. Then a1 only remains, then you can find a1. Let's put s equal to 0. What happens? Here 0 plus 1, 1. And here s for s equal to 0, it is minus 4. Here minus 4 a1. This is a2 into 0. Then you can find a1 is equal to 1 by minus 4. a1 is equal to 1 by minus 4 or minus 1 by 4. Similarly, putting s equal to 4 here. S equal to 4, what happens? 4 plus 1, 5 here. Here vanishes, 4 minus 4, 0. Here it is 4a, a2. Then a2 is equal to 5 by 4. Okay. Then what is the fraction here? Now, Given problem is now converted into fractions. Converted into a1 by s. What is minus 1 by 4 by s plus a2 is 5 by 4 by s minus 4. Then to find this inverse for L inverse of s plus 1 by s square minus 4. That is to find the inverse of this. To find the inverse of this, you can take this constant outside, minus 1 by 4 into L inverse of 1 by s plus 5 by 4 into L inverse of 1 by s minus 4. Okay. What is L inverse of 1 by s? That is 1. That is minus 1 by 4 into 1 plus 5 by 4 into L inverse of 1 by s minus a is e raised to at. Therefore, L inverse of 1 by s minus 4 is e raised to 4t. This is the answer. Minus 1 by 4 plus 5 by 4 and e raised to 4t. That is in some problems like this. It is not possible to find the inverse by the direct method. So in this case, we have to express the denominator as a product of linear factors, that is s into s minus 4, then converting it into partial fractions, each simple fractions, and find the corresponding a1 and a2. Method is multiplying the numerator by denominator both sides. Okay, and giving values, suitable values. So many problems are done in the notebook, just to see the problems. Okay, and next we have this, at most these type of problems can be there to find the inverse Laplace transforms. And next we discuss a result. It's a result that is if L of f of t is equal to, if L of f of t equals f of s, then L of e raised to at into f of t is equal to f of s minus a. It's a result. You just study this result only. It may have proof, but it's not asked in the question papers. But you just take this result only, and using this result you can do so many problems, such problems. Suppose you are asked to find the L inverse of, find the Laplace inverse Laplace transform of, question is e raised to 5t into t cube. Then you can see that you know L of t cube. L of t cube you know. L of t cube is equal to 3 factorial by s raised to 3 plus 1 or s raised to 4 or 6 by s raised to 4 is the answer. Then multiplying by e raised to at. L of f of t, that you know, f of s, a function of s. You got a function of s is here. But to multiply by e raised to at, then only change is just to change the s. S is changed to s minus. Here we are multiplying by e raised to at, that is e raised to 5t into t cube. Then L of t cube, that we know, f of s, capital F of s, is capital F of s. Then L of e raised to at into f of t, only changes, s changes to s minus a, that is s changes to s minus 5. Then the answer is 6 by s minus 5 all raised to 4. Okay, so simple, easy method. That is whenever multiplying a function by e raised to something, then it is easy to find this inverse Laplace transform using this result. Okay, using this result. Suppose we have to find the inverse Laplace transform e raised to minus 3t into sin t, whatever. Then e raised to 18 f of t. That is f of t that we know. L of sin t we know. L of sin t is, L of sin kt is k by s square plus k square. L of sin t is 1 by s square plus 1 square, or 1 by s square plus 1 is the answer. This is f of s, capital F of s. But to change, to find this, only change is e raised to at into sin t. The only change is change s only to s minus a or s minus minus 3. A is here minus 3. Now s is changed to s minus minus 3 or s plus 3. Then the answer is 1 by s plus 3 whole square plus 1. Okay. This is another method to find the inverse Laplace transform. In such problems, whenever a function is multiplied by e raised to at, then you can apply this result to find the inverse Laplace transform. Okay. And next we consider another result, that is Laplace transform of derivatives. Laplace transform of derivatives. That is, what is the Laplace transform of f dash t? So derivative of the function. Then Laplace transform of f of t, that you know, multiply it by s. S dash is first derivative, and multiplying by s raised to 1 minus f of 0. Next, to find Laplace transform of f double dash t, then we have to multiply L of f. This is a known thing. This is the result that we know. Then using that result to find its second derivative's Laplace transform, just multiply it by s square. S square. Okay. Then s square into L of f, second derivative, s square minus s diminishes. S square is changed to s all minus. After this first term, all are minus. S into f of 0 minus s vanishes, f increases, f dash is 0. Okay. In the case of triple dash t, s cube into L of f of t, then s diminishes, s square, s ഇങ്ങനെ പോകും. പിന്നെ എഫ് ഓഫ് 0, എഫ് ഡാഷ് 0, എഫ് ഡബിൾ ഡാഷ് 0 ഇങ്ങനെ ഇൻക്രീസ് ചെയ്യും, മറ്റേത് എസ് ഇങ്ങനെ ഡിക്രീസ് ചെയ്യും, അങ്ങനെ പോയാൽ മതി. അപ്പോൾ ഫോർത്ത് ഡെറിവേറ്റീവിൻ്റെ ആണെങ്കിൽ എസ് റേസ്റ്റ് 4 ഇൻറ്റു എൽ ഓഫ് എഫ് ഓഫ് ടി എഴുതുക, മൈനസ് എസ് ക്യൂബ് ഇൻറ്റു എഫ് ഓഫ് 0 മൈനസ് എസ് സ്ക്വയറിൻ്റെ എഫ് ഡാഷ് 0 മൈനസ് എസ് ഇൻറ്റു എഫ് ഡബിൾ ഡാഷ് 0 മൈനസ് എഫ് ട്രിപ്പിൾ ഡാഷ് 0. ഇങ്ങനെയാണ് പോവുക. ഇതാണ് ലാപ്ലേസ് ട്രാൻസ്ഫോം ഓഫ് ഡെറിവേറ്റീവ്സ്. അപ്പോൾ ഈ റിസൾട്ട് മാത്രം പഠിച്ചു വെക്കണം, ജനറലായിട്ടുള്ള റിസൾട്ട് പഠിച്ചു വെക്കണം. അപ്പോൾ ഇങ്ങനെ ഡെറിവേറ്റീവിൻ്റെ ലാപ്ലേസ് ട്രാൻസ്ഫോം കാണുന്നത് എന്താണെന്ന് പഠിച്ചു വെക്കണം. ഓക്കെ, പ്രൂഫൊന്നും പഠിച്ചിട്ടില്ലെങ്കിലും ഇതൊക്കെ പഠിച്ചു വെക്കാം. പഠിക്കാൻ പറ്റുന്ന ഇതാണ്, ഈ റിസൾട്ട് പഠിച്ചു വെക്കാം. ഇത് ഉപയോഗിച്ചിട്ട് ചിലപ്പോൾ നമുക്ക് ചില പ്രോബ്ലംസ് ഒക്കെ വരും. അത് മിക്കവാറും നമ്മൾ ഉപയോഗിക്കുന്നത് സൊല്യൂഷൻ കാണുന്നതാണ്. അങ്ങനെയുള്ള ക്വസ്റ്റ്യൻ ചോദിക്കാറുണ്ട്, സോൾവ് എന്ന് പറഞ്ഞിട്ടുള്ളത്. ഓക്കെ, അത് നമുക്ക് അടുത്ത വീഡിയോയിൽ നോക്കാം. ഓക്കെ, താങ്ക് യു.